Hello there, and welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp, and I am the founder of Utrema Limited, and we make premium fertilizers, novel biostimulants, and organic biopesticides. And we do have some biological living microbial products, but none that we sell into the hydroponics sector. But today I want to talk about one that I've never sold and never had any dealings with, but is really interesting. And that is the idea of applying endophytes to plants as a biostimulant. Now, endophytes are a beneficial bacteria or a beneficial fungus. And rather than, say, a mycorrhiza, which lives around the plant roots, or the plant growth promoting rhizobacteria, or PGPRs for short, that live in the soil and feed the plant roots, these sort of beneficial symbiotic microbes, endophytes actually live between the cells in the tissues of the plants. And these can be beneficial, but if you're a micropropagator, then obviously if you're trying to get sterile conditions, they can be a disadvantage because they contaminate the agar gel that you're trying to grow your micropropagated plants on. Some plants contain lots of endophytes, other plants don't. For a while, we didn't even know that endophytes existed. It required powerful and very precise microscopy to discover them. And a lot of microbes can't be cultured, so you couldn't just dab a leaf into some agar and find them. So we'll go on to what they are, what they do, and potential products that contain them. And you should find this fairly interesting. So what they actually do and how they help the plants, often it's many of the same functions that a beneficial microbe, whether living outside of the plant, may confer, such as drought, salinity, heat or cold tolerance, osmotic regulation, altered hormone signaling, and improved water relations. So maybe it produces a hormone or a biochemical that helps the plant resist stress, or it might eat up the precursors, metabolize the precursors to deleterious hormones. So one very common thing that microbes do is they metabolize ACC, which I don't know what that stands for, but it's a precursor to ethylene, which normally is an inhibitory hormone. Other things they can do is they can help absorb iron by producing a chemical called a siderophore, or they can solubilize phosphorus. And in some cases, they can even fix nitrogen inside the plant tissues. And that is where one of the big companies in endophytes has been working, a company called Azotic Technologies. I'll talk more about them in a second. And then obviously biotic stress reduction. So can they help suppress pests and diseases as they attack the plant? So a famous case study is the cool season pasture grasses host the epicloe fungi. That's interesting because it's got an umlaut over the E, and I've never seen a scientific name that has an umlaut on it before. Let me check if that's correct. Yes, it is. Every day is a school day, and today I learned that you can have an umlaut in a scientific name. And yeah, epicloe is a systemic and seed-transmissible endophyte of tall fescue grasses, endemic to Eurasia and North Africa. Wow, that is pretty impressive. And this endophyte helps protect the grasses against insect attack. Some fungal endophytes confer habitat-specific stress tolerance. The same fungus from a hot spring grass can make a crop more heat tolerant, while a coastal isolate may confer salt tolerance. And this idea underpins many modern products that you can buy for cereal crops. So they're taking the endophytes from wild grass plants and then trying to put them into grass crops like wheat they're not adapted to heat or salt-like conditions. So really interesting concept there. And as we say, these are systemic, so they're all around the plant, and they can actually get into the seed, which a lot of microbes cannot. There are some caveats and some safety issues with them, though. Pasture endophytes, the insect protective alkaloids, they're like an alkaloid is a nitrogen-containing compound, a special that's often to do with antiherbivory. They can affect animal health if the wrong type of microbe is used. So the people who sell these endophytes have to be really certain about that. And then the yield outcomes with nitrogen-fixing endophyte bacteria can be mixed across environments and programs. So some of the companies, many of the companies that sell nitrogen-fixing bacteria over-egg how much nitrogen they can actually deliver. So there's some really big agrochemical companies that have invested heavily in microbial biostimulants and microbial biostimulant companies that have said this will replace, say, 50% of your nitrogen, and the farmers have reduced their nitrogen by 50%, and it's not been replaced by the microbes because everything comes with a cost, and nitrogen fixation is very energy intensive, whether you're doing it with microbes or with Haber Bosch factories. So the big company Corteva, did they used to be Dow? I don't know. I've given up they always change their names, a lot of agrochemical companies. They've got a microbe called Methylobacterium symbioticum SB23, or Blue N, and that's an endophytic foliar bacterium that enters via stomata, colonizes leaf cells, and fixes atmospheric nitrogen into ammonia. Sounds great, doesn't it? We put on loads of crops, not just cereals, sugarcane, ornamentals, and things like this. The technical sheets emphasize endophytic colonization, and company trials show variable yield response. So I've not heard of that one before, so it's not taking over the world. The one I have heard of is Azotic Technologies Envita, and that's an endophytic nitrogen fixer, and the species is Glucanacetobacter. And I think Azotic Technologies comes from a spin-out from Nottingham University. They were pushing it for many, many years, almost like decades. This Azotic Technologies was a spin-out that just sort of sat there. And then recently they had loads of investment, and you saw them at a load of trade shows. And as I say, I'm the founder of Utrema, and we're a bootstrap company. We don't take investment from, the City of London or Wall Street. All the profits come from selling products, and we sort of build it up sustainably like that. And we often exhibit at trade shows or visit trade shows, and it can become a bit depressing almost, to see startup companies in biostimulants just come along with massive stands and loads of investment and loads of people and a shiny stand and shiny people, beautiful staff and things like this. And so, we're going to take over the world. And you're like, oh, blimey, have we missed a trick here? But then you might see them for a few years and then they sort of disappear. You don't see them at the trade shows again. And so almost when you're in the biostimulant industry and you're fighting for your life, it's always good to remember which were the companies that were really big and which were the technologies that were really big and that are no longer there. As I say, Azotic is still around. They've had a big bump of investment recently. But if we look at their balance sheet on their balance sheet on Companies House in the UK, we can see that they have got returned earnings last year of minus £24 million. So that doesn't tell me that they're selling a lot of product, and they are heavily got a lot of money invested in this, and things have to turn around fairly soon for those investors. They were minus 16.5 million in 2023, and they're now minus 23.28 million pounds. So not enviable from my perspective. A lot of biostimulant companies, they sort of advertise and celebrate getting investment. And for me, that's I've been around a long time in biostimulants and fertilizer, and I would never celebrate selling part of my company and getting investment. I only celebrate sales and profit, because that leads to the building of a sustainable company. And so different strategy to the likes of Azotic Technologies. But I can see, and that's also why we don't go for massive patents, but companies like Corteva, they're probably going to patent and they trademark their products because they are building shareholder value, and that is just as important to them as profit is. And so there are a number of other of these big companies that have got patented microbes, like Syngenta. They've got their endophytes for nitrogen fixation. Some years they make a big deal of this at trade shows. Other times you struggle to find them being mentioned. Depends what the emphasis is that year. Adaptive Symbiotic Technologies, AST. They have a product called BioTango, which sounds great, doesn't it? I wonder if it's orange. Tango is an orange drink from the UK. Again, it's abiotic stress resistance. You will find that most of these, even though the microbe might do really well in functioning like heat and drought resistance or salt stress or even phosphorus mobilization, they will focus on the nitrogen fixation, and for one reason only, really. And that's because you get to go to, say you're a small company and you're looking for investment from Syngenta or Corteva, or you're looking them to buy you. If you say you're a nitrogen fixing product, you can say, if we took just 1% of the nitrogen market worldwide, we'd be worth X billion pounds. And that everyone goes, wow, this company could be worth X billion pounds. And so they can have something they can hold, they can put their coat on and say, this company is worth this. Whereas if they said, we've got this amazing product and every crop we apply it to has increased heat stress tolerance, everyone would be like, well, what's the market value for heat stress tolerance, Dave? I don't know, Alan. What is the market value for heat stress tolerance? Oh, I don't know. Well, there's nothing we can value this then. And so that's why everyone goes for nitrogen fixation, because they know what the nitrogen market is per year. And they say, right, if we had 1% of that, we'd be all billionaires. And that's not the case often. So I used to work for a company that claimed to have nitrogen fixing bacteria. And I was like, this doesn't fix nitrogen. There's no way this product contains nitrogen fixing bacteria. And my boss at the time was a bit of a charlatan. He said, no, it has to, because that's what the shareholders are expecting. So a little bit of insight into the dirty world of biostimulants and microbial biostimulants there. What other crops and products have we got there? There are endophytes. Well, it looks like most of them are in grass species, so either cereals or grazing grass. Must be that is the easiest crop to infect, should we say, with an endophytes. And other species like dicots, there aren't many that go on to dicots. Certainly not seen many crops where endophytes have been promoted for use on things like tomatoes, cucumbers, things like that. If we're looking at it, it's mainly pasture and arable, possibly because it's much more difficult to infect those types of plants with endophytes, and they are less common in nature. Maybe the endophytes are specifically focused on grass. If you're an endophyte expert, then let me know, and I'm happy to do a clarification and an update. I just did a quick ChatGPT search, and it's found a number of studies where endophytes are used on tomatoes, but not for nitrogen fixation mainly. It's mainly for antifungal activity, showing antagonism, where it's not direct action, it just sort of keeps the pathogen from attacking. So things like Rhizoctonia, Fusarium, Botrytis, Alternaria, many of the wilts, the rots on tomato crops, and then also on legal cannabis. Again, there's a fair amount of research on endophytes from what many would call land races, and there's one species as well, Bacillus frigoritorans, and strain C1141. And they're from low domestication lines, so what we would call wild types or wild strains. What that Bacillus frigoritorans actually does in these strains, these low domestication lines of cannabis, is unknown. So that one is up for research if you are a microbiologist or you study that crop. So I think this is a really interesting area of study. As I say, it's one where there is a lot of money that's gone into it, but not many big products have come out of it. Some nice products. A lot of companies like Syngenta, Corteva like these products because there's a nice warm fuzzy story around them, an environmental impact of reducing nitrogen use. So they can sell that alongside the selling of pesticides, and so it's something else to talk about other than buy this bottle of pesticide and it will kill weeds or fungus and things like this. There's a nice, sort of regenerative agriculture line around it. So even if it doesn't make them money, they might invest in it and sell it to farmers because it sort of brands them as being the forward-thinking biological company. And many of the distributors will do exactly the same. Whereas somebody like Azotic or Indigo Ag or Adaptive Symbiotic Technologies, they are standalone companies and they have to live and die by the endophytes they can sell. So for them, it's much more of a bigger deal, and they have to produce sales and get distribution and get people buying it. That's tough. Even if you have 1,000 trial data, say 1,000 trials saying this product works amazingly, from farm trials, from independent trials, from university trials, doesn't mean the farmer's going to buy it. If you said, I've been to farmers and said, this product will increase your yield by 20%. And I went to every commercial greenhouse in the country because it controlled mildew organically. I said, you don't need to take your staff out of the greenhouse. You don't need to, you can spray it on right up until the day of harvest. They still didn't buy it. I could have put all of the independent data in front of them. That doesn't matter. If a customer doesn't want to buy it because they're bored, they're not bored, but they're lazy, then it doesn't matter. So that's the problem. A lot of these companies think that the farmers are going to be as really interested in the technology as they are. And if they don't get their marketing bang on, then they're in for a world of pain. And that's because endophytes are classed as biostimulants, and biostimulants are a vitamin and not a drug. They don't solve problems. They don't cure diseases. They just make the crop a bit healthier and a bit stronger. They are not going to be life and death. So if a farmer has £100 to spend per hectare on inputs, then they're going to go fertilizers and pesticides first. And if they have any money around, they might put it in the bank as savings, or they might, if they're feeling flush, buy a biostimulant, but definitely not going to be the first thing on their shopping list. And so that's the problem with a lot of these technologies. And then the other thing about these technologies is, do they actually work? Can you actually get them into the crop in the field? And with endophytes, it's a lot harder than it is with a lot of microbials and other biostimulants, because you have to actually make sure that the crop absorbs the microbe between its cells, and plants are often adapted to keep microbes out, and they don't want microbes and bacteria going through their stomata and things like this. This is the whole point of plants, is they're very good at keeping out infection. So that's why perhaps there's very, very hit or miss results when it comes to trial results with endophytes. If you've trialed using endophytes and you've had success or failure or any other insights, things I might have missed, things I might have got wrong, then please let me know. If you found this episode in any way useful and it's not the worst podcast you've ever listened to in the world, then please could you leave an Apple podcast review, as it would shoot the podcast up the charts and make more people listen to podcasts about hydroponics, because they'll see it higher up in the charts. If you're listening to us on any other streaming platform, ignore my request for a review, because it doesn't really matter, because it's only Apple podcast charts that matter apparently. But thank you very much for listening. And if you would like to get in contact with me, go onto the Utrema website. If you can't spell Utrema, it is Latin for wasabi. So just Google wasabi and then copy the Utrema from that. So wasabi is Utrema japonica. And I just like the word Utrema. I thought it sounded like a good sort of forward-thinking agrochemical company's name. So that's why I named my company after Utrema, after wasabi. And also I love wasabi. I like growing it. If you're all probably really, really bored now. So I'm going to say goodbye, and I'll see you tomorrow. Goodbye.